Hello everyone, this is Mohammad Asad Amin, lecturer in Physics, Education and Literacy Department. Regarding SIN College Lectures YouTube channel, I would like to deliver you a lecture on a topic astronomical telescope from chapter number 10. I hope you will find this lecture informative and interesting. Introduction. A telescope is an optical instrument used to view heavenly bodies such as moon, stars, planets and distant objects. Now the diagram or the ray diagram of telescope is showing that this telescope is in normal adjustment, in which the final image is always formed at infinity, so that the eye is completely relaxed when viewing it. Construction. The construction of astronomical telescope is based on two convex lenses. The first lens is called objective. It is usually made up of two convex lenses in contact with each other to reduce the chromatic and spherical aberrations. The objective is a convex lens of large focal length and large aperture, so that it gathers more amount of light. The second lens is called an eyepiece, which is also a convex lens, but its focal length is smaller than that of objective. The objective is mounted on a wide metallic tube, while the eyepiece is mounted on a small tube. The distance between the eyepiece and the objective can be changed by moving the tubes. Working. The rays coming from a distant object falls on objective as parallel beam at some angle, say alpha, and these rays, after refraction and passing through the objective, converge at its focus and make an inverted real image, which is of very small size. This image is denoted as AB in the diagram. This image acts as an objective for the eyepiece. When telescope is focused for infinity, the distance of the eyepiece is so adjusted that the image AB lies at the focal length of the eyepiece. The eyepiece forms the final image. The final image is magnified, virtual and inverted with respect to object. The final image is formed at infinity. Magnifying power or angular magnification. As we know that the magnification or the magnifying power of a telescope is defined as the angle subtended by the final image at eye divided by the angle subtended by the object at eye. It is because the object is at infinite distance, and hence the angle subtended by the object at eye may be taken as the angle subtended by the object at objective. So magnification is equals to beta upon alpha. Since alpha and beta are small angles, therefore we can take alpha is equals to tangent alpha and beta is equals to tangent beta. Now magnifying power is equals to beta upon alpha, as we defined it earlier, and in the diagram you see you are having two right angle triangles AOB and AEB. Now if you consider the first triangle AOB, So according to the angle alpha, if you calculate the tangent alpha, which is equals to perpendicular upon base, so according to the diagram it's become equal to AB upon OB. Now in the second triangle AEB, if you consider an angle beta, so the tangent beta is again equals to perpendicular upon base, and according to this diagram perpendicular is AB and base is BE, so it would become AB upon BE. Now because magnification is equals to beta by alpha, and if you keep the value of beta and alpha in the equation, you will get AB upon BE divided by AB upon OB. Now AB and AB cancels with each other and the magnifying power is equals to OB upon BE. In the diagram OB is equals to FO and BE is equals to FE. So the equation for astronomical telescope magnifying power is FO upon FE, whereas FO is focal length of objective and FE is focal length of eyepiece. Length of telescope. The distance between objective lens and the eyepiece is equal to the length of the telescope. From figure, OE is equals to length of telescope, which is denoted by L, but OB is equals to FO and B is equals to FE, or length of telescope is equals to FO plus FE. L is equals to focal length of objective plus focal length of eyepiece. This expression shows that in order to obtain high magnification, focal length of object must be large and that of eyepiece is small. Introduction. Whenever any object AB is placed at a distance D, which is least distance of distant vision from an eye, it subtends an angle directly on an eye called visual angle and is denoted as alpha as shown in the diagram. The apparent size of an object depends upon its visual angle subtended on the eye. The greater is the visual angle, the larger is the apparent size of the object. Now in the diagram, D is the least distance of distant vision, which is 25 cm or 250 mm for a normal human eye. A convex lens of short focal length is used to see the details of an object when an object is placed within its focal length. Such a lens is called magnifying glass or simple microscope. Magnifying power or angular magnification. Magnifying power or angular magnification of magnifying glass is the ratio of visual angle subtended by the image seen through a magnifying glass to visual angle subtended by the object when placed at the least distance of distant vision when seen through the naked eye. The magnifying power is denoted or represented by an equation beta upon alpha, which would be our equation A. In the diagram, AB is an object which is placed at a distance D, which is least distance of distant vision, and it subtends an angle directly on an eye called visual angle and is denoted as alpha in the diagram. Now these visual angles are very small, therefore we can take alpha is equals to tangent alpha and beta equals to tangent beta. Now here I am not talking about the angle beta, rather we have denoted our angle here in the diagram as an alpha. So if you consider right angle triangle ABE, So tangent alpha is equals to perpendicular upon base, which is AB upon EB. Since tangent alpha is equals to alpha, therefore alpha becomes equals to AB upon D, which is our equation A. Now in the diagram we have kept a lens in front of an object, and now when it is seen through a lens, it subtends an angle beta to our eye. Now if we consider right angle triangle OPE, tangent beta is equals to OP upon PE, and as you know that tangent beta is equals to beta, so beta now equals to OP upon P, which is our equation B. Since OP is equals to AB, which is height of the object, we have considered AB as the height of the object in the previous diagram. So now beta is equals to AB upon P, which is our equation C. Putting the values of beta and alpha in equation A, magnifying power is equals to AB upon P divided by AB upon D. Now AB and AB cancels with each other, so you will get magnifying power equals to D upon P, which is our equation D. Now here we will use thin lens formula, according to which 1 upon F is equals to 1 upon P plus 1 upon Q, such that P is equals to plus P, Q equals to minus D, because the final image is virtual, and F equals to positive F for convex lens. So 1 upon F is equals to 1 upon minus D plus 1 upon P. So 1 upon F is equals to minus 1 upon D plus 1 upon P. When you multiply both sides by D, you will get D upon F equals to minus D upon D plus D upon P, and D upon F is equals to minus 1 plus D upon P. Now 1 plus D upon F is equals to D upon P, or D upon P is equals to 1 plus D upon F, which is our equation E. Comparing equation E and D, we get magnifying power equals to 1 plus D upon F, which is our required equation for a simple convex lens behaving as a microscope.